Okay, good evening everybody. I hope everyone's having a wonderful day. I want to welcome you to CS 210. So, my name is Dr. Daniel Page, but you can just call me Dan or Daniel. I'm really excited to be working with you this term. If you find yourself needing to reach out to me on an easy basis, my email is daniel.page@uregina.ca. And there's going to be more details and ways to reach out to me. So for example, I will have ample office hours available. I'll be getting to that in a moment. But before we do that, I just first want to make sure I welcome everybody to the class. I'm really excited to be an instructor this term. I consider this course a rather important one in one's studies in computer science. So I'm hoping that the things that I teach you in this course will be beneficial down the line in your future studies. So anyways, I'm going to move on over here to get to the course outline. Now, one thing I need to point out is I have difficulty seeing the chat from when I'm over there. So if you have a question that can't be addressed immediately, just put it in the chat. I can take a look at it after I go through the course outline. If not, just verbalize it towards me. Just turn on your mic and just interrupt me while I'm chatting on the other screen over here. So let me just boogie on over here. So just get on over here. Okay. Here we go. Here we go. A little bright. I'm a little bright here today. So anyways, that being said, here's the course outline. So you may have read some of this before. I'm just going to highlight some important aspects of the course outline before we get started. So first, as you know, our lectures on Tuesdays and Thursdays. You guys are here, so you probably know that already. Office hours. I have office hours Tuesdays, Wednesdays, and Thursdays. I tried to spread them out throughout the day because I know there's some students taking classes more in the evening. I know there's some taking a little earlier on. I know there's some taking about the middle of the day. So I tried to split out the hours. So I made sure I tried to make myself rather available. So just stop by any of these hours at my Zoom office hours, and I'm very happy to help you out, okay? So just prerequisites. So there are two prerequisites, a Math 110 and CS 115. Makes sense. One thing also I do want to point out to you, and this is something that's going to sound a little weird at first, is that I'm going to expect you to know some C++ programming because you probably, if you've been through 115, you've probably seen plenty of C++. I must stress that if you've not seen C++, I'll expect you to be able to kind of pick up this programming language. I put a pretty good resource there, cplus.com. But if you find yourself needing more resources, I'm going to point out a book that will be rather helpful for if you need yourself just some extra background. But also, there's a lot of resources on the internet, and just feel free to reach out to me if you've never seen C++ before. I'm very happy to help point out some resources. But just be aware that I'm going to just expect you to have that background. In this course, you will see some more programming concepts. But I must stress that I wouldn't consider this course a programming course. It's a course on data structures and algorithms, it sounds a little weird at first, but I assure you it will make sense eventually. So just be aware of that. We will use the object-oriented paradigm for programming in this course. So just be aware of that, okay? Is that okay with everybody? But yeah, you might see that and be like, Dan, what do you mean by this is a programming class? Well, you're going to do plenty of programming in this course, but it won't be really the core of this course. Instead, you're going to see that we're going to talk a lot more about a lot of these ideas in a way that isn't really tethered to one programming language. But we're going to see how different ideas can compare and contrast. But also, especially, when we start getting down to really the bread and butter of this topic, which is really about algorithms and data structures, which aren't tethered to any one programming language. So I'm hoping that you'll see this distinction. It'll be rather helpful, say, if you were, say, picking up C++, or you're picking up a programming language like Java or Python or some other programming language, that the ideas you see in this course will be very helpful to translate from any one programming language you want to work in. So I'm hoping that that'll be very helpful for you to see. I'm just keeping an eye on the chat just to see if there's anything big over there. So hopefully that's clear, everybody. Is that okay, everybody? But yeah, so don't worry, you will get to do some programming in this course. You'll find that there'll be a mixture of programming and concept-based assignments. So I'll get to this in a moment, okay? So one thing I want to point out is that this course does not have a required textbook. I will not require you to get a textbook. Some of you will be like, oh, phew. This is by design. I like to keep the courses generally well self-contained. So I will be providing lecture notes after class. So if you find yourself having difficulties taking notes with us on the board here, I will be posting those notes on our course website. But if you find yourself needing a supplemental text, the one that I've referred to here is actually, I would argue, is one of the closer texts to what I'm going to be covering in this course. So if you find yourself really needing a good one to look at, this one might be a nice one to transition between and in the way I'm talking about, where we talk a little bit more about these abstract notions of algorithms as opposed to more of a programming concept of an algorithm. That, and also if you want to see some more C++ based or C++ syntax based code, this is a pretty good book. There's lots of books. Most of them will generally do pretty well for a course like this. So just as a general gist of what you're going to be in for, just remember, I must stress that this is not a required textbook. I must stress also that if you find yourself needing an additional perspective to look at, I encourage you to seek out additional sources or even the optional reference text. But it's not required. I just wanted to point that out because some people like to really just have a whole bunch of extra code they can look at, and this book is generally pretty good. But it's not required. I'm not going to require a textbook from you. Everything in this course will be self-contained, and a lot of the resources you'll be able to find are pretty easy to find on the internet, which is pretty great. I'm just going to see if there's anything going on over there. Actually, let's see if I can grab it from over here. I got it. Okay, perfect. I got the chat. So now I can see the chat. Perfect. Sorry about that. Question, is there a specific C++ version we should be using? Now, here's the great part, is that I will just be expecting you to be able to compile your programs in G++. As for version, I'm not going to be, if I need some very specific detail around this, I will let you know, okay? So like if there's a very specific way I want you to compile the program, I will let you know. I'm usually very explicit in my assignment specifications. So hopefully that helps a little bit with that. I will be giving you some more details about those things as we get closer to the programming assignment in the class, or at least the first programming assignment. But it's a wonderful question. So anyways, with that being said, let's talk a little bit about what the main topics in this class are. So first, we're going to start kind of revisiting one idea you may have seen in 115. That's actually going to be the first thing we're going to talk about in this class is abstract data types. So you've probably seen or maybe you've heard these in 115. Well, I'm going to talk a little bit about them a little more just to remind you of what they're about. And I'll give you an example of these. And we're going to talk about data structures very often in relation to abstract data types. So once we're done and through that, I'm really going to start getting into the fundamentals. So I'll start talking about data structures, a working definition of an algorithm. So just a general intuitive notion of what an algorithm is, what a problem is, what concepts like input size are. We're going to talk about a lot of pieces that are going to help us when we want to build our toolkit for analyzing algorithms and data structures. So we'll talk about analysis of algorithms, how we can look at general performance of these algorithms from more of I don't like to use the dreaded M word, but it's a rather important one, the mathematics behind some of these things. I'll sometimes playfully call it the mayonnaise. We'll talk about asymptotic notation. I'm not sure if you've seen big O notation before. If not, we will definitely be talking plenty about big O notation in this course and how you use it and what's the definition of it. And we'll playing around a little bit with it. We'll talk about analyzing running times of algorithms. I'll come and pick some examples of things that you may have seen in 115. We'll talk about recursion. Oh, good. No, wonderful. So we'll talk a little bit about recursive algorithms and how you can analyze them using basic techniques like iterative substitution. Then we'll talk about sorting. Now, I must stress that we may cover these topics in a slightly different order. So some of these I might cover earlier, some might get covered later. But this should be a general framework for how it's going to kind of play out. So once we're gone through kind of these fundamentals of the ideas here, we're going to talk about sorting. So you talked a bit about sorting algorithms probably in 115 quite a bit. You probably talked about some different sorting algorithms there. We're going to talk about some more here. I'm just going to kind of walk us through some of the main ideas with these. We'll look at how we can analyze some of them. And then we'll look at recursive sorting algorithms. So ones such as merge sort and quick sort. And as time permits, I might talk a little bit more about some very specific so-called pivoting strategies. It's a little technical jargon for you. That changes up how the performance of quicksort can vary. So we'll talk a little bit about that, and depending on how much time we have, we might talk about so-called non-comparison based sorting, which is it's really interesting in its own right. So once we get through sorting, we'll talk about linear data structures. So some of these you may have seen a little bit about. If not, we're going to definitely go head right into all of this. We'll talk about lists, stacks, and queues. So I'll talk a little bit about actually what a stack is today, just to give you an idea of what an abstract data type is, or just as a little review. We'll talk about dictionaries. Fundamental data structures-based problem is a so-called dictionary problem. We'll talk about this in this class. We'll talk about some basic ways to implement a dictionary. And then we'll be moving into a topic called hashing, which is really a fascinating one. It shows you really naturally how you go from this trade-off between using space to make up for time versus using a lot of time but very little space. So you're going to see there's going to see this interesting trade-off phenomenon that's going to happen with a lot of our algorithms. Hashing is a pretty good example of one where using some memory, we can actually speed up a lot of operations, and in very specific circumstances, under certain statistical assumptions, we can actually get really, really fast algorithms for our operations for a dictionary. Usually in the average case. But yeah, we'll see how we can resolve these so-called hash tables and things like that. We're going to have a good time with it. Then we're going to move into talking about trees and tree-based data structure. So I'll talk about trees, some terminology around trees. We'll talk about ordered dictionaries. We'll talk about so-called binary search trees. Then we'll talk about a very special kind of binary search tree called an AVL tree. It has a very neat property that allows you to get search times in a tree-based data structure that stores a whole bunch of these interesting records for a dictionary, so that the searches can take logarithmic time. It's actually what we would call a self-balancing tree. So this structure actually is able to self-maintain itself so that it maintains a special balancing property in the so-called tree. It's very interesting. So we'll play around with those. Then we're going to talk about more general families of tree data structures called multi-way search trees, such as 2-4 trees and B trees. So this is the general gist of what the course will contain, at least from our side here. The labs cover some more concepts. I know they talk a little bit more about some more programming concepts, which will be very helpful for the assignments, but also help you give you a flavor for how you can take advantage of some of the OO-based features of C++. So are there any questions? Any questions about this so far? Or are we doing all good? Okay, so if we're doing okay, let me proceed. So what's a week like in this class? So just come to a lecture. We'll have our Zoom meetings for that. Do you keep in mind, like I said previous to recording, the big thing I want you to take from this is that I'm also going to record these lectures and they'll be up on the YouTube channel. There's a link here for the YouTube channel, but it's also on the course website, all of these links. Also, of course, attend your lab section. So if you registered for a lab section, make sure you attend that section. As you know, our sections are delivered remotely, so it's nice and accessible in that way. There will be assignments in this course. There'll be a blend of written and programming assignments. And there also will be a scheduled midterm and a final examination. I'll talk about those two things later on, okay? As I mentioned previously, I encourage you to take notes during lecture. This is often very helpful when you're learning material like this because a lot of it gets a little bit more abstract and you will see a lot less code in this class. you'll see a little bit more of an abstract notion of what code could look like, so-called pseudocode in this class a lot more. So it's often very helpful to see and try and rehearse this by just simple mechanisms like taking notes for yourself. So I will be doing notes on the board, and consider these lectures a part of the experience of this. So when I write notes, I do them with the entire class. One other thing I need to point out, office hours are over Zoom. You'll find the link on the course website, and this is the link right here. Just keep that in mind, that I do have scheduled times for my office hours. I tried to make sure I had plenty of hours available across a few days. So I don't think I need to explain to everybody here about Zoom etiquette. You can take a look at that if you'd like. Course mark. So as you know, there are labs in this course. That's 10% of the course grade. There are 5 assignments in this class. 2 of them are written assignments. 3 of them are programming assignments. So you might ask, Dan, what are written assignments going to look like? You'll find that I will be talking a bit more about some of these more abstract ideas of like, okay, so what do we mean by an algorithm? What do you mean by, efficiency of an algorithm, and a little bit less of a way from talking about programming and more about just the algorithms themselves. We'll spend more time playing around with a lot more of these ideas. Maybe I might even ask you to design me an algorithm at some point. So we'll see that more in kind of the written assignments. So you'll get to try out maybe some of the algorithms that we've seen in class. You'll get them try them out on pen and paper. Or if you want to type them up or you want to draw them out, that's all good. All the programming assignments will be done in C++. I'll have more details about the programming assignments when we get closer to that. But yeah, no, I expect them to be pretty, for at least students that have been through a 115, they should be pretty... like the setup for them, you'll find that I have very precise specifications for everything. So there's going to be very little room for ambiguity when you're working on these assignments, but it's also a task for you to translate the specifications into what would code be. So just keep that in mind. A lot of the programming will be based around trying to implement the ideas I show you in class. So it won't be that where I just throw something random at you and be like, oh yeah, there's this thing, implement it, and you've never seen it in class. You'll be something you've seen in class, and your task will be typically to implement what you've seen in class in C++ a lot of the time. Or I add some little wrinkle to it to get you thinking about how you can solve a certain problem. I'd like to make my programming assignments pretty fun. So I'm hoping that you'll feel the same way. It's going to be a lot of work, but I'm hoping it'll be very rewarding. But yeah, you'll find that all the assignments, you'll be given 2 weeks to complete them. So I like to make sure you have plenty of time to work on them. So that's a big thing with me. I want to make sure things are a little bit flexible. That's just generally how I am, regardless of the delivery of a course. I'll get to more about these due dates here on the assignments in a moment. But yeah, there's a scheduled midterm on March 1st, and the final exam's on April 19th. The final exam's worth 40% of your grade. But yeah, no. There's just some details here about student responsibility, emails. Yeah, there's just a format I'll be expecting the written assignments in. So I will put this always at the top of the assignments to make it a little easier for you, just so in case you don't have to come back to this document. It'll be in the written assignment, so you just have it right there in front of you. So for example, I expect a title page, and you can write up your assignment, you can type it up, you can use your tablet, write out your answers. You can do that. That's all good. The big thing with written assignments is you're going to submit me as one single PDF file. Okay, so one thing I want to be clear about is just make sure you don't hesitate about trying to give details in your solutions. Now, what I mean by that is that if you're not sure what to do, just give it a try. A lot of the time, these assignments, especially the written ones, will involve you. They may involve a little bit of trial and error, trying to figure out things. So do take that time to do that, and then you can always come along and you can refine your answers when you write them up in your assignment. But if you're really just not sure or you're really low on time, just don't leave things blank. It's often very helpful to complete your work or try to complete some work. It illustrates some matter of understanding. Now, for the assignments, the programming assignments specifically, just carefully follow the specifications I give you. I also talk a little bit about coding conventions, so make sure you follow well well-designed coding conventions. I'll usually list these for you in the programming assignments. Just certain things I'll keep an eye out for. And of course, one thing I must stress that I'm not sure how it is in 115, but usually in 210 and on, usually my expectation is that you know how to compile C++ code. So the expectation, the bare expectation in this course will be that when you submit code to me, I'll be probably running some tests against it, and I'll expect that your code can compile. And if your code doesn't compile, then that could be a problem. That may mean that you might lose quite a few marks. So just be aware of that expectation here. I like to be very transparent with my students about just general expectations, so I'm hoping that's clear for everybody. I know it's a little like, oh man, well, that kind of makes sense. Yes, the code has to run to get full marks in this class. That's what I'm saying. Can you work it on Replit? Well, there shouldn't be any issues generally working in different interfaces. I will give those details when we get closer. I'm still trying to decide at this time about whether I want to commit to a given IDE or if I want to just keep it where it's easy enough to implement whatever IDE you choose. It's just as long as it compiles with G++. I'm still figuring that out on my side. But I'm hoping it will be very clear and transparent for everybody when we get there. Yes, I know. That's somebody's bringing up about a Mac. They're on a Mac, and that's exactly it. And I want to make sure, because we're doing this remotely delivered, that all of our stuff works regardless of which operating system you use, and it's very simple to pick up. So what if our code logic is correct but made a very small error? Now, I should be very clear about this. So when it comes to this, so the big difference here is about compiling your code. It's okay if your code if your code fails a certain test. If, say, the TAs are running your code and it fails a test, that just means you'll get a penalty for failing a test. That doesn't mean you're going to make a major penalty or something. The point here is that when I go G++ and I enter in the command, it better compile. That's what I'm saying. Otherwise, you may lose all the marks associated with tests. But there will be code marks dedicated to the code itself. So just be aware of that. So there will be usually a substantial marks, usually about half, roughly, associated just with the code itself. It's just the general idea is that I want to make sure that when you're careful when you're writing up your code, that it makes sure it compiles. That's a very important aspect at this stage. Because remember, like I said, I'm going to expect you to know C++. Now, there's another good question here. Programming questions are to be submitted via any CPP file. Yes. So I'll be expecting you to submit me specific files. So usually I'll give you some files to work with, and then I'll ask you to write, like, say, a class for me in a CPP file, or give me, like, a header file and a CPP file. It may be something along these lines. Most likely it'll just be where you're submitting me, like, 1 or 2 CPP files for an assignment. That's going to be most common what will happen. So usually I'll give you, like, a header file or 2 and maybe some other file. And usually the idea will be that you just have to implement an aspect of the whole program. So usually my assignments, I like to try to instill the importance of designing efficient data structures. So usually I like to translate a lot of the ideas that you see on the board into things that really you could put on a computer, and they actually are very effective. So in a class like this, I'll try to give you some assignments that'll actually show you, okay, so I can actually implement programs that actually have where, like, the inputs could be in the thousands, and it actually works very efficiently. So we'll have approximately 1 to 2 weeks per assignment. It's 2 weeks per assignment. So if you take a look at the schedule, the way it'll work is I drop an assignment down, and I drop it on the same day the assignment is due. The previous assignment is due. But yeah, no, so I'm hoping this is understandable at this stage. But yeah, no, so just keep in mind that I will give you more details about programming assignments when we get there. I don't like to leave students in the dust with this stuff. It's very important that my expectations are matching up with what you are expecting. But Yeah, no, so when we get there, I'll give you more details about that. But that's the expectation I'm going to have in this course, is that code that doesn't compile may not lead to good grades. But keep in mind, that doesn't stop you from submitting code that may not compile, but may have a lot of the ideas there. But it just may not reflect in a good grade. Okay, so one thing I want to point out is that there's no late assignments in this course. There is no late assignment policy. However, I must stress that one thing I have not written here on paper is that actually, because of the nature of this course, because it is remotely delivered, and I know that there are students that are taking this class all over the place. And I want to make sure, in case there's any technical issues, that students, if say, for example, your internet goes down, it's really close to the deadline or something, that there's still opportunity to submit it. But in a more practical way, it makes sense to have a little bit of flexibility, even though I say no late assignments will be accepted. Usually I mean by the end of the day. So let me just point this out just for one moment. I know there might be some interesting questions about something like this. So for example, if I give you assignment 1 and I tell you that the deadline is February 2nd, keep in mind, I will write all this down for you and I'll keep repeatedly reminding you of these things during the term. So this won't be just one thing I'll just say at one time. So if I tell you the assignment is due by the end of February 2nd, what will happen is I'm going to allow you to submit, well, it says by the end of February 2nd on paper, because nobody's going to look at your assignment at 3 a.m. I like to be flexible about this. So if you submit, say, the next morning before 8:30 in the morning, that's okay. I will not penalize you for this. But if you submit anything after 8:30 in the morning, that following morning, then I won't accept it. Is that clear, everybody? So there will be some flexibility about, like, okay, if there's any issues around that midnight. But I must stress that this is also a good way just to make sure that if you have any issues, whether it be technical, that that's a good way of putting it. But I'm just talking about accessibility here. So for me, it's mostly just about making sure that if there's any technical issues, that you can submit your work without any issues. So my justification is, okay, the deadline is the end of February 2nd, but if you can't get it in by 8:30 in that following morning, then I won't look at it, okay? But that's just there just in case. But if you want to use that time, you may use it as well. I will not penalize you for it. But hopefully that's okay with everybody. But yeah, no, so that's my policy around this, because it keeps things nice and simple and streamlined. The other reason why is because I like to make sure that I can give you solutions for the written assignments right away. So you don't have to wait 2 weeks for a sample solution. I could just give it to you pretty quickly. The other thing is, usually for solutions, I don't give them for programming assignments, because usually I design the programming assignments so that it has some form of testing involved with it. So the TA will tell you what thing failed, what method or function failed, and so on. Oh, I see there's a question. Yep. Mohammed, what was your question? Yes, of course, of course. Yes, it's important for me, because a lot of the time when it comes to office hours, those are the times where if you're really just not sure about something, you come and bug me. I'm happy to answer any questions. Yes, usually the office hours are the best place to come and bug me about more delicate or much more kind of broader questions, because sometimes there's very technical things in this course, and sometimes it's really helpful to have that one-on-one kind of back and forth where you can show me something, I could show you on something on the board. It tends to be rather more productive than just over email. But if you do send me an email, by the way, just to be clear with everybody, I usually am very quick to respond by email. So it's usually one of the quicker ways to get to me. So I usually keep a close eye on my emails. If you find yourself having any questions, it's usually a good way to get to me pretty quickly. But yeah, office hours, yeah, come by if you have any questions about the assignment or if you have any concerns. Whether it be something in the lecture and you're not sure about something, or you're curious about something from the lecture and you want to learn a little bit more, come on by my office hours. I'm happy to chat about it. Okay. One other thing I wanted to point out is that the assignments, there's a regrading policy that I'm going to be putting into place. This is just to keep the course running smoothly, because I want to make sure that you're keeping track of your marks, but at the same time, if there's something like that that is an issue, that it's addressed quite quickly. Otherwise, I don't want to have it where we're talking about assignment 1 at near the end of the term. It should be addressed pretty quickly. So so there's going to be a policy that when an assignment grade gets released for you, so when your assignment gets graded, there'll be 2 weeks to reach out to the TAs or myself to assess what happened. Or if you have any, well, generally, if you have any questions, you're happy to come and bug me about it. But when it comes to this policy, this is specifically about if you found there's a counting mistake in the grade, or if there's a dispute about how many marks you lost on something. The pecking order works like this. Reach out to the TA that marked your assignment first. If there's a disagreement or the TA doesn't address your concern, then you come and see me, okay? So that's just generally going to be the policy. So when you get your assignment back, take a look at what the TA had wrote for you for feedback. But then also, if you're not sure about anything, ask the TA directly. If the TA doesn't really give you a satisfactory answer, come bug me, okay? So a question about proctoring. So now this is one of those, what I would call sort of like, I don't know, the best way I could describe it. This is, so there is proctoring being used for this course, for Proctor Track. It's being used for the midterm and final. Now, I see the Proctor Track more as just a tool to ensure that people understand that somebody's at least watching them. I personally am not the biggest fan of this type of software, personally. But I do think it's important that some people appreciate having something keeping an eye on them while they're doing their test. And that's the purpose of this Proctor Track, at least in this course. So for the midterm and the final, the Proctor Track will be used. So proctoring may be used. Historically, has it been used? Yes, the exam and the midterm are both closed book. Yeah, they're both closed book tests. But yeah, so Proctor Track will be used for both of these. That's actually why on the course website, you'll see that I ask you to complete an onboarding quiz. This is to ensure that you can complete the midterm and the final. It requires you to complete a profile check, the so-called the onboarding process. So please complete that as soon as you can. I'll ideally like it before the first week of February. This is just to ensure that you can complete the midterm and the final. But yeah, it's one of these things I'm not the biggest fan of, but it's just there. But yeah, no. So when it comes to the tests themselves, the midterm will be taking place at a scheduled time on one of our class times. It is closed book. There won't be any makeup tests for it. And it is, I usually like to make my midterms not worth as much grade-wise so that you can look at it more as an opportunity to get some experience with the kinds of questions I can ask you on the exam. So that's at least the main purpose of the midterm, is to give you some flavor of what kind of questions I can ask you and get a general flavor for the kinds of expectations I'll have for you for this course when it comes to the written examination. I must stress that that my goal here when I do these tests with you is to examine your understanding. It's not to get you to take a test for the sake of taking a test. It's about examining your understanding of the material that I'm covering in class. So you'll find very much that the material around the midterm and the final will be very closely related to what we see in class. Okay. No, thank you. No, thank you. Yeah, no. So the final exam's at a scheduled time. It's in the evening, so it's going to be quite a late night. Usually we have 3 hours for the exam. I normally design the exam so it doesn't take the full 3 hours, but you have the 3 hours to complete it. one thing I want to point out is I may try to get it so that you can get 3 hours and 10 minutes just for accessibility reasons in case you need to upload any files. I must stress that I usually design my tests so that everything can be completed digitally within a quiz module on your courses. So generally, you'll be able to complete everything without having to upload a whole bunch of files. So it's usually done, and I do this deliberately so that it keeps it so that you don't have to worry about going back and forth between scanning or taking pictures of things. It keeps things nice and simple. But those options will be available. So if you need to upload a file or something, it's going to be there. Okay. Yes, the exam will be in a quiz format, just to clarify. Yes. Yeah, so it'll be formatted as on your courses as a quiz. But yeah, I'll give you a very clear idea of what these exams or tests will look like. So I'll usually give you an exam format or a midterm format. It'll tell you exactly what kind of problems to expect, what I'm going to cover, what I will not test you on, and it'll also I'll tell you what the written questions will be about so that you know exactly what to study for when it comes to those problems. I usually like to be very transparent with my tests. So that you have a clear understanding of like, okay, this is what he's going to be asking me to do on the test. But yeah, so one thing I want to point out is very important is academic integrity. Now, I'm sure you've heard this spiel before. I'm going to try to give you my own wrinkle on this. So the assignments in this course, they are an opportunity for you to apply the knowledge that you see during class time and to play around with the ideas that we see during class. So you got to look at these assignments and the tests and so on as opportunities to do this. So if you take this opportunity from yourself by looking up the answers somewhere, or getting your friend to do your work for you, or finding somebody on the internet to do it for you, you take that opportunity away from yourself. But you're not only doing that, but you're cheating yourself from the opportunity to learn it learn and apply those ideas. So a lot of the time, these assignments are rather helpful for translating that knowledge from what we do in class into something, whether it be an abstract idea or something that's translating it into actual code. So these are good opportunities for you to try these things. So when it comes to the assignments and so on, just keep in mind that all the assignments are individual efforts. They're not a group project. So do keep in mind, I do take these things very seriously. And I do pursue them to the fullest extent. So when it comes to that, I do want to make a couple remarks. I've been a tutor before. I used to tutor years back. I think did it for like 5 or 6 years. Now, I know what a tutor does. A tutor's job is to help you understand course material. However, don't ask a tutor to do your homework for you, okay? Whether it be an in-person one or your friend or an online tutor or consulting somebody, don't get them to do your work, okay? Your work is yours. It's assigned to you. It's an opportunity to apply the ideas that you play around with in class. You're going to find there's going to be a lot of those kind of opportunities in this class. So I'm hoping that you will not abuse those things. But tutors, they're very helpful. Their job is to help you understand course material, not to do your work for you. If you need an accommodation, obviously reach out to the Center for Student Accessibility. I'm very happy to accommodate for a lot of things in this class. I try to make my classes generally accessible regardless. So most things that people ask for accommodations tend to fit very perfectly into what I'm up to. I know very perfectly sounds really weird to hear from somebody at this time of the day. I know, right? Just generally, recording policy, I already told you about this before we got started. This lecture will be recorded and posted on the YouTube channel. It will not contain your name. It will not contain any private information unless it's elicited to me. So for example, if I call upon you or something. I generally try to avoid doing that in my lectures just for the sake I try to respect people's privacy. When it comes to that, just generally keep in mind that these are going to go up on YouTube, but only stuff that's going to be relevant, that's going to be in these recordings, is anything I say or anything on the board or anything that you're looking at on my screen. It won't be containing your classmates, their video, or pictures, okay? So just some general tips, just to be helpful with you. And this is actually a very good tip when it comes to academic honesty. Is if I encourage you to talk to students about your assignments. So if you're not sure about something, talk to classmates about it. Sometimes that's actually a rather helpful way to learn about things. So talk to your classmates about things. It is allowable, of course, but remember, and this is actually a really good tip I can help you with. You have a conversation with your classmates. You can talk about it. If somebody has a question for you, just a general conceptual question, that's okay. But if you're working on an assignment and somebody's talking to you about a specific part of the assignment, make sure nobody keeps records of what happened in that conversation. So meaning that don't take a picture of it. So like if it's on a whiteboard, for example, don't let anybody pull out their smartphone and just go like this to the board. This encourages you to go away from the conversation and write it up yourself. So if you find yourself working on an assignment, do it separately from your classmates. It's usually a rather nice way of avoiding issues with plagiarism. But do keep in mind that we do look for these kinds of things when we're looking over the assignments and whatnot. And do note that with programming assignments, I typically do use software to check code. So just be aware of that fact as well. So for example, I use MOS, which is a pretty standard program for checking similarity between different codes. So with that being said, are there any questions? I just have a couple small other remarks, but other than that, that's generally the course outline. Just don't cheat. Don't cheat. It's an opportunity for you to learn about and apply the ideas. I'm here to help. That's really what I'm hoping that you're getting that impression from me. I'm here to help you learn this stuff. So I'm hoping that you'll respect the trust that everybody has, because I want to make sure everybody's being treated down the middle. Okay. So a question about, is this course in link to CS 201? Now, I couldn't answer that one because I haven't taught 201, to be honest with you. But a lot of the ideas that you'll see in this class will be very helpful for many future courses you take. So I must stress that this is one of those courses you're going to find that a lot of the ideas you see in this class are going to kind of leach themselves into a lot of other courses. In fact, there may even be some overlap with them. So two other things I wanted to point out, just generally, just some advice I can give you. But yeah, no, I'll just be assuming that you have some first-year programming background with some basic algorithms, some basic math background. I'm not going to be expecting anything too crazy. I'll be starting right at fundamentals when it comes to these more abstract ideas. But some things will come up every once in a while where it's like, yeah, you need to know your 115. But yeah, no, so just a couple tips. I recommend starting the assignment several days before the deadline. I know some students are like, oh man, these people always tell me this, but I always want to do it the night before because it's a pro gamer move or something. I recommend not doing that with the assignments in this course. I recommend taking them in pieces. So just take them in pieces, especially the programming assignments. You'll find that the way I write the specifications out, you can take them off in little pieces, so you can like chip away at the assignments. So you'll find that it's very easy to kind of work your way through the assignments by doing them in bits and pieces. And the conceptual assignments, you'll find that as I cover material, you'll be able to do more of the assignments. So I do this deliberately to help you make sure you kind of keep pace with your assignment. But I can't tell you what to do, but that's just my recommendation. You'll find that it saves a little bit more time because I know you're probably taking other courses too. Other things, if you find yourself writing emails to me, just keep them concise. It usually makes it a little easier to parse out what exactly you want to get help with, or if you have any questions about something specific. Sometimes it's a little exercise to help keep things simple. When it comes to the optional text, you'll find that there's a lot of material there that can be helpful for if you need more examples. So just keep that in mind. if you find yourself needing more examples, sorry, I'm just running out of air. I'm just really excited. If you find yourself needing more examples, especially true with some of the more abstract things we're going to talk about in this class, don't hesitate to reach out to me. I'm happy to make more examples. I'll put them in the lecture notes even. Okay? And just, if you find yourself opportunities to meet with students, that's usually a good idea. Actually, I do have a question for everybody. I'm not sure if anybody has set up one, but something that I know a lot of students benefit from is having a Discord server. If any student in this class wants to set up one, or if there already is one set up, oh, you made one. If you could put a link in the chat, I would appreciate that. So if any students want to hop on in, it makes things a lot easier. I'll sort of be ghosting, or I'll post some fun memes for you. So, yes, yeah, no, it's wonderful. But yeah, it's another place you can reach out to me as well on Discord. So, that being said, I'm going to move on back over there. So let's head on back over here. I'm just going to get the chat back over there. Okay. So before we get started here, are there any other questions? Or do you think we're ready to go? Give me 2 thumbs up. I see some thumbs up. Give me some 2 thumbs up. And we'll get started here. Okay. So let's get started here, okay? So I'm going to start off by kind of breaking down some of the more kind of the main concepts in this class. So you're going to find that I'm going to talk about a lot of definitions at the first parts of this course. Some of them you may have seen before, other things may be new. That's wonderful. That's wonderful. So some of this you may feel, Dan, we talked about this before. That's okay. That's okay. I just want to make sure everybody's on the same footing here. So anyways, we're going to head over to this board. I just wrote up a little spiel here before we get into things. So the first thing I really want to talk about is really just one of the major ideas in computer science. So a big part of computer science is about the study and solving of computational problems. And you'll find in this course that a lot of what you're going to see is centered around this idea. It's not going to be centered around programming. It's going to be centered more about problem solving. That's going to be kind of our big thing. So that being said, when we talk about a couple of things here, I'm going to be focusing in on 2 main parts, hence the name of this course. So yeah, I know this camera has a mind of its own. Sometimes it's moved in one direction on me. It makes things like a little fun here. But there's going to be 2 main things that we're going to talk about a lot in this class. I mean a lot. Is how we organize data. So these are so-called data structures. So this is the general gist of this, is a systematic way of organizing and accessing or modifying data. So you've probably seen or heard a little bit about data structures previous to this class, but we'll talk and pin down this a little bit more fundamentally. So another element of what we're going to talk about are so-called the recipes, the ways and hows to solve a problem. These are through algorithms, which you can think of as a step-by-step procedure for performing some task in finite time. So we'll talk a lot about both of these in this class. So you're going to find that I'm going to first talk a little bit about this, and then I'll talk a little bit about this to help motivate and give us a general gist of where everything is at. So is everybody okay with this? If we're okay with this, I'll start talking about so-called abstract data types. So you may have heard of these in 115. Okay, so let's head on over this way. I'm going to kind of boogie on over this way. And let's talk a bit about data structures, because we need to have some consistent language when we're talking about these things, especially when we start pinning things down in this more formal way. So let's talk about what a data structure is. But to do that, I need a few things. So let's talk a little bit about data structure, seeing as that's the first thing I listed over there. Okay, so the first thing I need to talk about is a data type. Now, so let me write out a definition for a data type. It's a rather broad concept. So a data type is a collection of values or objects that, now you're going to see this is going to be where it gets a little bit strange if you're just thinking only about programming, that can be mathematically, that's a dreaded M word, the mayonnaise. Mathematically specified. So that means I'm giving you an exact specification of what exactly it is. So giving you an exact definition. Exactly specified or given concretely. So it means that you actually have this thing manifested in something like software, given concretely in a programming language. So something like C++. Now, often we would like to have some way, of talking about a model for one of these data types when we have operations associated with them. This is what we're going to refer to as an abstract data type. So there's going to be a careful way I have to define this for you. So let me talk about what an abstract data type is. Now, you may have seen this before, but you may not have seen it the way I'm going to talk to you about it. It's going to be the same idea. It's just you're going to find that I'm going to write it in a very different, it may be a little different. I'm not sure exactly how you've seen this concept before, but you'll find that this will be very natural for the way we're going to talk about data structures in this class. Question about, so I encourage you to take notes with me. We work together to develop the notes. But as I mentioned earlier, all the lecture notes, so these lecture notes will be posted on the course website after lecture. So that's for accessibility reasons if you find yourself having difficulties taking notes. But it's also a good reference. That's also why we don't have a book in this course. It's not required. So, abstract data type. So it's a very similar definition to this one. But there's this abstract word here. I got to talk about what that means. So it's simply a collection of values. The U here sort of melted in the microwave. It's sort of like bent. That says values right here. Values or objects. Now this is the part that's going to be a little bit weird. Actually, no, this part isn't. What's coming up after this is. And a set of operations. A set of operations on those values or objects. Now this is the part that's a little weird at first if you've not seen this before. That is accessed only through an interface. And I must stress that an interface defines its supported operations. So, you might ask, what's this about? First, has anybody heard about interfaces before? In some programming languages, interfaces are a very direct mechanism that's actually a part of the language. Some languages, it isn't quite a direct one. It's actually something you have to implement in a very specific way. For example, C++ is an example of one such language that is more of the latter. I'll talk briefly about that, and I will actually have an example that's going to be in the notes to show you what one of these would look like. Yeah, it's very similar to like if you think about a header file where you specify all of your member functions. What I would like is have some way I talk about those signatures. So the signatures, like the name of the function, the parameters or inputs of that function, the return type, those signatures. I would like to have some way I know and specify these. So what the interface's job is to define all of these member functions and their signatures. And this is the only way for which I access the operations. So it's more of a, it has two purposes. One, it actually operates like a formal definition for what the data type should be and its operations. But it also actually functions nicely if you think back to object orientation. If you think about object-oriented programming, this actually enforces a nice practice that you may have seen before. So-called data abstraction, where you keep all that information hidden away so that if you want to implement one of these so-called abstract data types, you can implement it by inheriting the class that's actually this interface in C++. So you just inherit it, and then you get to take on the definition of the abstract data type. Just the big thing here is that the abstract data type's operations are going to be defined through one of these so-called interfaces. So just a couple things I want to point out about that. Mostly things I just said here a moment ago. The big thing I want you to notice is that I'm saying it's only accessible through this interface business. The big thing I want you to take from, don't worry too much about the technical details about what this is for now. Right now, just think about it this way. The ADT describes the type of data stored and the operations performed on them. But, now this is the part that's going to make it distinct of what an abstract data type is compared to something else that you may be familiar with, but not how it does it. So you could just think of it like a definition. So we're going to see an example of one of these in an example in a moment. But you think of it like I'm giving you a definition of the type, and it has some set of operations. These are the definitions that I'm talking about. So you want some way to define what this data type is, but I wanted to describe it in a way so that if you were to implement all of its operations, you may even implement more if you like. As long as you've implemented all of its operations, then you could call whatever you've implemented as that ADT, you can call it that. So just to give you an idea of what I mean by this, just because I need to make sure I'm clear about this. So these are obtained through so-called public interfaces. So programming languages like Java actually have this feature actually cooked right into them. It's really nice. In C++, this is actually obtained through doing something a little different. Now, you may have seen this in 1.15 briefly. If not, you may have, I'm certain you've seen about classes before. I'm sure you've seen classes before. So the way you'd obtain one of these interfaces, a common mechanism for doing this is through the construction of so-called abstract classes. So what is an abstract class? An abstract class is just simply a class with at least one. And this is the technical jargon here. Please forgive me for the sake of this. With at least one pure virtual member function. So it has to contain at least one pure virtual member function. So if you're just to parse this out, a virtual member function, this keyword virtual is one in C++, which what it does is it allows you to redefine. So if you're using inheritance, so we're calling inheritance, you have a base class, you can inherit and create derived classes from those base classes. The keyword virtual gives you the functionality of so-called overriding or redefining the member function of your base class. So you can have both the original member function of your base class or anyone up its hierarchy, but also you can redefine your own. That's the big thing when it comes to the so-called virtual member functions. Now, this pure part, and this has got to be the weirder part about this, is the pure part of this makes it so that the member function actually doesn't specify the body of the code for the function. So what do I mean by this? When you specify the class, whether it be, say, part of your header file, or it could even be straight up a class file, like it's literally like your class. You can literally just simply write, now this is where it gets a little weird, is when, say for example, I want to make it so that the function is purely virtual. What you do is you actually write equals 0 after the signature of the function. It's kind of weird. I have an example that's going to be in the notes. So I'm going to ask you to take a look at the notes after class to see what I mean by this. I also give some couple references to the C++ website. If you find yourself curious about virtual functions, they're a really neat feature. But yeah, this is how public interfaces can be created in C++. It's not quite as nice as a language like Java that has this feature caked right into it. But you'll find that this feature is something that you can get in C++. It's because C++ has a lot more functionality with the way inheritance works. That's why you'll see it's rather general. But this should give you a flavor for what exactly I'm going to mean. I'm going to give you an example now. Are we okay with this so far? Okay, so question about public interfaces. So actually, if it helps at all, let me show you the example first. It may help you understand why we might define data structures in terms of these ADTs. So let me show you the example, and this might help a lot with this so-called idea of the public interface. So remember, the idea here is I would like to have some formal way to define a data structure for you. And I would like to have it so it's clearly and exactly specified so that if ever I want to implement your abstract data type, I have an exact definition for it, and I actually have a mechanism to define it for myself. So that when I want to pick it up and I want to say, hey, look, I want to make something of your type, I can do that. So the part that makes the ADT what it is the fact that it's only accessed through an interface. So the concept of an interface is an abstract one. So this could be something that is actually, like, you don't actually have to think about it as programming code. It's a formal idea, but it can be a programming one. So you got to look at it more like you're looking in through the window and somebody tells you, hey, look, I have one of these things. If you want to implement one of my things, you got to implement all of my operations. And the way I do that is by only and necessarily requiring somebody to actually implement all of my operations. So I require that. So I'm going to do an example just to illustrate this, because I think it makes things a little bit easier to see with the concept of an ADT, because it's a little, no pun in, actually is pun intended, it is abstract. For some, it's a little abstract. So don't worry, that's okay. So we can define ADTs for all sorts of data structures that you're going to see in this class. So you can define you'll find that when you see an example of it, it gets a lot more concrete what we're doing at this. You can define ADTs for stacks, queues. So these are some of the abstract data types we're going to see in this class. Stacks, queues, or data structures, depending on what lingo you would like to use. Trees, and more. We're going to see a lot of different data structures in this class. So we're going to define a lot of these as we go through the course. So I'm going to start off by just introducing you to the idea of a stack. So let's consider the idea of a stack. So before I write anything down, you might ask, Dan, what the heck is a stack? So imagine somebody has a stack of plates. Now, with a stack of plates, you can imagine if each one of these plates was some element. So suppose one of these plates represents some element. And I would like to stack them up into a whole collection like this. And here's the idea. With my stack, the rules are quite simple. I'm allowed to do what we call a push operation, which means I put a plate on top of the stack. So for example, I can push this orange plate onto the top of the stack, but I can't put the orange plate below the green one. So I could keep pushing plates onto the top of the stack. And each one of these is going to represent some element. And this may be some other data type, like an integer. It could be many different things. The point is that we have elements, and I can push them onto the stack. That's one of the major operations, is pushing elements to the top of the stack. You push them onto the top of the stack. Think of it just like a stack of plates. Now, imagine I'm only allowed to look at the top of the stack. I'm not allowed to go to the bottom of the stack. I'm not allowed to go in the middle. You can clearly see that it would take a lot of force for me to go in the middle of this and yank out a middle one, right? Here's how the other main operation works with a stack, is you pop. So the other operation is called pop. This is what you do, is you pop off the top of the stack. This removes it from this collection of elements. And then I get the element that's on my plate. So I could pop off the top of the stack. So I could push elements onto the stack, or I can pop them off. But another set of operations that also it includes is something called peek. So that allows me to examine the top plate. So I can look at this and say, that's the orange plate. So I'm allowed to do things like this. So these are how I would define operations, for example, for my ADT. So notice that I didn't say anything about any code whatsoever. I didn't even tell you how to implement this, right? But the point is I would like to have a definition for a stack so that if you pick up a stack and say, hey, look, I want to have one of these stacks. I want it to do what I just described here, where I could push elements onto the top of the stack, or I can remove them from the top of the stack by popping them. How would you want to peek at the bottom plate? Now here's the here's the unfortunate thing. The definition of a stack doesn't actually have that operation. You can always define it if you wanted to, but the definition that we're working with a stack doesn't actually have a peek operation for this bottom plate. I'm only allowed to look at the top of the stack. Now you might ask, Dan, why would you make it so the stack is only visible to the top of it? That's it for another day. We'll talk more about that later on in this course. There's a lot of reasons why you might have a stack that does something like this. But the general idea is that, notice that I gave you some idea of a series of operations, how you manipulate the data on my stack. And I would like some way to define this. So I'm just going to define these operations, then we'll stop for today, and then we'll talk more about the stack when we get back, okay? So let me just quickly write this on out. So I got to write a definition for a stack for you. A stack is a collection objects, and I see in the chat point this out, collection of objects that follow. Now, there's a technical name for what I just described with the way I access the elements that follow. And it's called last in, first out. If you're not sure what that means, so it's abbreviated as LIFO. Just think about when I pushed elements onto the top of the stack and when I popped them. Think of the order in which you would access the elements if I pushed a whole bunch on and then I popped them off. That's where it's coming from. So it uses LIFO rules for insertion and removal of objects from the collection. So, like I said, you can think of it like a stack of plates. So, just as an example, you can think of this as a stack of plates. So I do some examples actually in the notes. So if you find yourself looking at this and be like, can you show me what each of these would look like and what would the return value and all that look like? I got you covered. There's a lot of examples in the notes. I'll do some more actually next day. But more formally, a stack, so this is the proper definition here. A stack is an ADT that supports, that says supports over there, supports, we'll be in and out of here right away. I apologize for going a little longer here. The following two methods. Now, I must stress, so methods or operations, that I'll tell you up front. I am very much one of these types that comes from the Java world, and we like to use the word method a lot to talk about member functions. So if you see me ever using the word method, it's an abbreviation for member function. It's sort of scoffed at if you're working in C++ to call member functions methods, but just to be clear, that's what I mean when I say method. So when you ever see method, just assume I'm saying member function. So you have push and you have pop. So push, it adds an element E to the top of the stack. And pop, it removes and returns the top element from the stack. Now there's some other operations as well that you can have for a stack. For example, you can have, there's a few of them. For example, some other ones include peek. So I already told you what peek is about. Some people call this top. There's also size. This tells you how many elements are in the collection or in our stack. And you may have one called isEmpty, for example. It tells you if the stack is empty or not. So the idea is that I give you this definition of what a stack is, and then what happens is if you can implement all of these operations, then you could tell me that your object is a stack. Is that clear, everybody? So when we come back, I'll talk more about this example. I'll reinforce some of the ideas that we talked about over there. I'll include an example in the from the notes of a stack, and maybe I'll get a little ahead here and I'll include the example with the interfaces in C++. That way you could see what I meant earlier about what one of these interfaces would look like in C++. But when we come back, we'll come back to this example with stacks, okay? So I apologize for going a bit longer here. I'll keep an eye on that. So that being said, I want to say thank you very much and have a beautiful evening. I can stick around for a little bit if anybody has any questions. So everybody have a beautiful day. I'll see you later.